You should be able to see the question here. One of two complementary angles has a measure that is 6 more than twice the others.
Okay.
Find the measure of the larger angle. Can you see that? Is that clear on your screen on your
Yeah.
side?
Yeah.
Okay, great. All right. So what does it mean for something to be complementary? Do you remember that from class?
Yeah. They add to 90 degrees.
Up to 90. Okay. So I'm going to call X is going to be angle 1,
Uh-huh.
and Y is angle 2.
All right.
So if they're complementary, we know that X plus Y equals 90. That doesn't help us because we have one equation and two unknowns.
Mhm.
But it says that 1 is twice more than the other. So we're going to say that Y is 6 more. 6 more is plus 6.
Uh-huh.
Twice the other is 2x. So
Okay.
6 more is that. Twice the other is that. This is essentially a system. Are you
Mhm.
taking honors geometry?
Yeah.
Okay.
Honor.
So there's not a ton of algebra in this class, but you do have to do some of the things you did in your previous class, like systems, solving quadratics on occasion.
Mhm.
So you're going to substitute this into the equation here: x plus 2x plus 6 equals 90. Okay, and then we're going to solve this. So just to be clear, in geometry, kind of as a side note here, there's really two types of questions they sometimes ask. Sometimes they ask for x, like they just want the value of x. Great. Sometimes they want you to use x to get a measure. In this case, it's the measure of, like, it could be a side, it could be an angle, could be something else.
Uh-huh.
So you have to always be sure that you know what you're trying to do. Like when you get x here, you're not done. Like x is not the correct answer.
Uh-huh.
So keep that in mind here. So
All right.
this is 3x plus 6 equals 90. 3x equals 84. You're using the book Geometry for Enjoyment, is that right?
Yeah.
So this book was written a long time ago.
Yeah.
I might have even used this book. And they don't always give you nice answers. They do have fractions and decimals. It was written before calculators are really pretty prominent. This one does have a nice answer to it, but just keep that in mind. Just because you got a decimal or fraction doesn't mean that it's
Yeah.
so x is that. Now you could put this back into the equation, this one right here, but you can also put it into this one, first equation there. So y is 72. Usually you want to put a little degree symbol there for
All
that one. So given this format, I just want to remind you that if I have no way to know whether you really understood that or didn't understand it, so you have to be a little bit more
Yeah.
verbal. I can always give you another example if I can think of one. I can also, try to find one, but you have to kind of dictate that.
Yeah.
So
And
tell me
that,
where you want to go next.
yeah, makes sense. So that would be the answer?
Yes, this is the answer. Sorry for being unclear. The answer is 72 because we 28 is the smaller angle. This one's smaller, and this one's larger.
All right.
Could ask for either, of course.
Uh-huh. Okie dokie. And then I also had a question on number 24.
24.
Yeah.
One of the advantages, and there are some advantages of this format, is I think you get more of the words that I say down, and I take sort of better notes for you. And of course, like right here, I can just snip this in, and we don't have to worry about copying it over from the book.
Yeah.
Okay, so we're doing proofs. Proofs. There are three types of proofs that you might do. The first is, or the most common, I'll just say, is the two column. That's probably what we're going to do here. Is that right?
Yeah, that's what we've been working on in class.
There's also a paragraph proof and then a flowchart proof. If you really like proofs, there are classes in math and college that they are essentially based on just proving things, not actually getting like the number, which is very different than what you're used to. But some people really like it, and I don't want to discourage you from that because it's kind of a cool thing. So there's a statement side, and then there's a reason side. You
Yeah.
seen that?
Yeah.
Okay. I really like to do the following. Put the givens down, but as I write them down, angle F is congruent to angle 1, which is given. I also update the um, the picture here. So this angle is congruent to that angle. So
Okay.
there's several different ways to do it. Like you can do comma your next given. You can go 2 and then your next given. Uh, I guess I'll actually put that second one here because they're kind of in the same. So this angle, putting 2 marks there, 2 marks there. Those angles are the same.
Uh-huh.
Okay, and that's given. So do you know what kind of triangle FKG is?
No.
It's a okay, an isosceles triangle because you have 2 angles that are the same.
Oh, okay.
So that means that side FG and GK are the same. It's this picture right here where these are the same. So that means that these angles are the same. You're not there yet in the class, but and that's where I got to remember that I can't just jump ahead to some of those things.
Yeah.
Uh, um, so now we go to FK. FK is perpendicular to KH. So that means that this is a right angle.
Yeah.
Okay, but that is not what the given says. So the given says FK is perpendicular to KH, and that's given, but that leads to something. Like this leads to the fact that angle FKH is 90 degrees.
Uh-huh.
And like it's this is the oddity of like this class. It's like you can't just say that 2 plus 2 equals 4. You have to say that the commutative property is used to make this 4, even though
Uh-huh.
we feel like we know it. And then you got the same thing. You got GK is perpendicular to KJ. Let me actually put some appropriate symbols here. So that means that GK is perpendicular to KJ. So this one is also a 90-degree angle here.
Okay.
And we're trying to prove that angle F is congruent to angle J.
Mm-hmm.
Is that right?
Yeah.
Okay. Have you made any progress on this?
Well, I did it. Uh, I did it, and I just kind of wanted to know if I got it right or not.
Okay. You're welcome to send that to me by email. It's a little hard for you to. I don't really want to have you share your screen or your camera. So if it's
Yeah.
quick for you to take a picture and send it by email, that would be preferred. What is your next step here? What is your kind of your first non-given step though?
The first one I did is say that the angle FKH is a right angle.
Yes. Okay. So angle FKH. Did you say is a right angle or its measure is 90 degrees? The measure of
I,
angle.
I said it's a right angle.
Okay. Yeah. So angle is right angle, and you probably said the same thing for angle
Yeah.
GKJ.
Yeah.
What did you put over here on the right?
I put if two lines are perpendicular, then they form right angles.
Okay, so it's the kind of the a lot of times it's definition of perpendicular line segments, which is the
Okay.
same thing you said, but a lot of times it's definition of. It's like whatever whatever you got there.
Uh-huh.
Okay, so what did you do for step 4?
For step four, well, you kind of already did that with the other thing. I confirmed. I said that the angle KFH is. I mean, that angle GKJ is also
Okay,
a right angle.
good. Okay, give me the next one then.
Angle KFH is congruent to angle KGJ.
Okay, so that's right. So the angles are congruent. Angle FKH is congruent to angle GKJ. What was your reason over here?
I said if two angles are right angles, then they are congruent.
So more generally though, it's if two angles have the same measure,
Uh-huh.
and you have to use that word measure in this class. Measure means it's a number,
Uh-huh.
then they are congruent.
Okay. Yeah. No, I didn't.
Which is slightly different than what you said, but like some instructors are really, really picky about this. But the good news is you only have to do this for the first half of the class, and then you don't have to do it anymore.
That's cool.
Okay, so now where are you up to?
Then after that, this is that this is the part where I wasn't really too sure, but the next step I had was that like angle KFH minus angle KGH is equal to angle 1. And then I said that's because of like angle subtraction, but I don't really know.
Okay, so you're gonna use kind of a substitution thing in there.
Yeah.
Okay. So you're gonna say that. Okay, so you're gonna do this for both of them. Basically, you're saying that I'm gonna put angle 3 and angle 4. Is that what I heard? Like you're saying that angle K. Are you saying that angle 3 plus F adds up to 90?
No, I was just saying that if you like subtracted like the smaller triangle KGH from the bigger triangle, then you're left with like the other triangle. I don't really know if that makes sense, but
Okay.
what would we do?
Well, you're not in the part of the book where you can prove congruence of triangles. So you do have to kind of say that angle, um, basically angle F plus angle 3 equals 90,
Uh-huh.
and then um, angle this angle J plus angle 4 equals 90, and now that doesn't get us anywhere. Um, how about we don't know. Okay, so another technique here, and I'm gonna copy in this picture again,
Okay.
is to one of the things that's happening in this particular problem is that there are two triangles overlapping with each other, and it makes it very difficult to. So let me do it this way. That's K,
Uh-huh.
that's F, and that's H. So we have that one there, and then we have K over here. And then this is G, so let me label this F, F, H, and this is G, and then this is J.
Uh-huh.
And we have a third triangle. I probably should have made that slightly different. So we have a third triangle, K, G, H. We actually have a fourth triangle, K, G, H. And we have a fourth triangle that is the big one, K, F, J. So this is a technique, especially when you're kind of stuck. And then the and have you done this yet? Or just tell me if you've already done this.
No.
All right. So here's what we know. We know that F. Here's F. F. This angle right here in the big triangle is the same as this angle down here, and it's congruent to angle 1, which is this one right here. Is that okay?
Yeah.
I know we're kind of repeating information, but we do them in all three pictures to help kind of figure out what we got going on here. J J right here is congruent. That's J right there is congruent to angle 2. Angle 2 is that one right there. And the next thing, FK, perpendicular to KH. So this is a 90-degree angle.
Uh-huh.
So that means that this angle and this angle have to add up to 90.
Mm-hmm.
This is 90 over here, GK, KJ. They have to add up to 90 to this angle. That's what I was trying to show you earlier. If I call this, I went with 3 and 4. So let me do it that way. So I think I went 3 and 4. And this is the same KH, this is 3, and this is 4. You follow that?
Yeah.
Okay. Um, so you can say some things like, and I'm just going to call this F. So F plus 3 equals 90.
Uh-huh.
J plus 4 equals 90.
Uh-huh.
And we know that we need to somehow prove that angles 3 and 4 are congruent, and then you can prove that F and G are the same.
Mm-hmm.
Is that okay? I mean, that's where we're at.
Yeah. Okay.
Okay. So this angle up here, I feel like I'm missing something. That's why I'm sort of stalling here. Um, because we don't have enough to prove that F and 3 are the same.
Uh-huh.
But if we did, we would we would uh, we would we would be done. Like you can see that if 3 was equal to 4,
Yeah.
3 was equal to 4, we would be done. So okay, so K, angle K up here, we haven't looked at that. K is 1 plus, I'm going to call this 5. 1 plus, this is 1 plus 5 plus 2.
All right.
Um, so we know that F plus 3 is 90. So I think there's something here. I'm cautious here to keep going because I can see that this is going to take some time because we have to get all these equations lined up. But we see that K is 1 plus 5 plus 2. We know F and J. We might have enough here to get it. So I can proceed if you'd like,
Okay.
but that's, again, it could just be a little bit of hassle here. So let's see if we can see what we got here. Okay, so um, we've got 3 plus 4 plus 5 equals 90.
All right.
We've got F plus 3 equals 90. J plus 4 equals 90. And we've got, so angle 1 is really F,
Yeah.
and angle 2 is really J. So we've got FF JJ plus 5 equals, I'm sorry, this equals 180. This one equals 180. We've got F plus F plus 5 plus J equals 180.
Uh-huh.
So 1, 2, 3 variables. Oh, so 4 and 5 though are, don't we have, we probably already have, those are G and H. We don't have those. Let's see. We've got 2f plus angle 5 plus 2j equals 180.
Mm-hmm.
We know that, gosh, we just don't have enough here. Hmm. We really want to show that 3 and 4 are equal. Oops. Do you have any ideas here?
Not really.
um, okay.
I mean, I just, yeah.
Let's see. This is the, okay, let me just, so, okay, we have, um, I think I've got some overlap in in this. We've got 1, 2, 3 triangles, 4, 5, 6. Yeah, okay. There is enough here. Oh boy. Um, there's 1, 2, 3 triangles. I shouldn't do that. That's the wrong color. Um, there's uh, there's 1, 2, 3 triangles. The big one, 4, 5, and 6. So there is enough to do this. Boy, I hate to spend all this time on this. I'm sorry. Um, I would need to label. So this is F. This is J. We're gonna call this. So this is F also. This is J also, and this is this is 90 minus 2J down there. This is 90 minus 2F down there. Uh, this angle, I already used 3 and 4, so let me use 3 and 4. Um, and then this is 180 minus 3 minus 4. Um, so, boy, there's always something here that it's like this one little piece that you can't get, and then it prevents the whole rest of the proof going. So let me just back up here before I spend more time on this, and give you sort of the, like, if you can't get to the answer,
Uh-huh.
what you should do. The last step is the proof step. So angle F is congruent to angle J. Uh, Angle F, we actually don't know how many are in here. Angle F is congruent to angle J. I'm sorry, that goes over here. Angle F is congruent to angle J. And then the reason is something we don't know yet. But what leads to that? Well, somehow we prove that we agreed on this already. We proved that angle 4 is congruent to angle 3.
Uh-huh.
Because if we know those are congruent, then we know that the other ones are also congruent.
Yeah.
Did you learn, and this is where I got to ask, have you learned that this angle right here is equal to this angle plus this angle?
No.
Okay. All right. They're kind of really limited on this. You want to somehow prove that angle KGH is congruent to angle KHG. Basically, that angle 3 and angle 4 are the same. That leads you to this. So if you can't work backwards, it's like one of these, like, if I know that, then you write it down. If you can't prove it or can't show it, you want to still follow, like, you're not sure what the missing steps are, but you can at least get a few more in here.
Mhm.
It sounds like you're using the angle subtraction property in here, and I'm really struggling to get it. It's not obvious. Is there anything else we can work on today besides this problem to
Uh,
help you?
well, I have a test like in a couple, I think on like Tuesday or something. So just like general review for uh chapter 2.
Okay. Um, let me see. I guess I don't have the solution to this one. Okay, let's switch up our strategies. Is there any other review questions that you need to do?
There are, but I did those, and I didn't really have any questions with those ones.
Okay, this book also has a cumulative review, which gives you some more questions that you can work on. And I'm going to pull up my version of this book. And if you go right to the end of chapter 3, page 167, not sure if you've got that available to you,
Yeah.
but let's just look at, like, number 6 would be a question that you might see on your test.
Okay.
I don't know. I'll ask you about some of the other ones, but let's get to some stuff that and to be clear here, this is to close out this preview one. You want to write as many possible equations as necessary to find the um, the system that will be solved, system solved.
Mm-hmm.
And I actually don't know how many it will take, but it's quite a few. Um, the other thing here is it's symmetric. So like whatever you do to one side of the triangle, you're going to do to the other. But I'll let that go here. Okay, given AB equals 2R plus 7, so that's that one there.
Mm-hmm.
CD is 3R minus 1, and BC equals 6. And it does say that C is the midpoint of AD. C is the midpoint of AD. They want you to find the value of AC.
Mm-hmm.
Okay. How would you start this problem? What would be your initial step here?
This is a proof.
Say that again.
Is this a proof?
It is not.
Okay.
Proofs only would say prove
All right.
something. This one's just a numerical value.
Okay. Um, so the first thing I would do was is uh say that 2R plus 7 plus 6 equals 3R minus 1.
Okay, so here's what you said symbolically is that AB plus BC is equal to CD.
Correct.
Okay. All right. Go ahead and solve that. I'm going to look through this and see what else
All
we
right.
can find. How are you doing on this one?
Almost done.
Okay.
All right, I got 41 is AC.
What did you get for the value of R?
14.
14. Good. So it's 3 times 14 minus 1, which is 41. Great. All right. So this one, this next one I want to look at is a question like the one you first posed to me, and then we'll go do a proof.
Okay.
I'll make some more comments on proofs. So this one talks about it being supplementary. What does that mean?
Uh, they add to 180.
Yeah, and in this class, there's two things that you generally say. Either something is equal or it adds up to something.
Uh-huh.
So I actually like writing that out as a system, much more algebraically based. What's the other equation here?
Uh, and then x equals y plus 8.
So that does work. If you write it the way you just said, x equals y plus 8, you end up solving for y because you get y plus 8 plus y equals 180. That's not the most common way for us to solve, but it does work. So go ahead and work through that and see if you can find the value.
Okay. Okay, y is 86.
Okay, so what is x?
Uh,
And I recommend using this equation here.
yeah, 94 degrees.
Good. Okay. Um, all right, so the next question that I think would be good to work on, it's a proof. Um, it's kind of related to what we were doing, where I think you end up using some subtraction properties. One of the things that happens is that the proofs get a little bit easier when you know what you're supposed to be using.
Uh-huh.
And like this is not, you're not quite there yet, but some of these get a lot more straightforward when you do that. So PS is perpendicular to SR, so that means that this is a 90-degree angle.
Uh-huh.
So we're going to start with that. So I'm trying to start this one more officially. So the other thing is you don't have to write the givens down until you actually need them.
Yeah.
And that's usually a better way. So that's given. And then two is that uh, angle PSR is a right angle.
Uh-huh.
And that's the definition of perpendicular line segments.
Hmm.
The other thing is I always like to know, like, what am I trying to go towards? So angle S is congruent to angle QRS. Basically, this thing down here is also a 90-degree angle.
Uh-huh. Okay.
So we always want to know like what we're trying to prove. I should almost use a different color for that to make it clear. So not sure how we're going to do that yet, but we'll figure it out. It may be that we have to actually add in another segment here, which is also kind of a technique in these proofs where you have to do something else that's not given. So the next thing is that QRP, QR to P is complementary to PRS.
Uh-huh.
So so that means that this angle and this angle, they add up to 90 degrees.
Yeah.
So let's say that. So number 3 is that angle QRP is complementary to angle PRS. You should always be able to write down at least the givens and then like what the givens lead to. So that's another sort of helpful thing. Like we can say that the measure of angle QRP plus the measure of angle PRS equals 90. And that's another kind of straightforward definition of complementary angles.
Uh-huh.
So that's always a start here. Um, the next thing is that is that if PS if PS is perpendicular to SR, that means that SRP, the angle down here, SRP, and the angle SPR, they're also complementary.
Uh-huh.
So we can say that. We can say that angle SRP is complementary to, so one of the limitations here is I have to scroll all the time. SRP is complementary to SPR.
Uh-huh.
And well, actually, I take that back. We actually can't do that yet. We have to say that angle S, the measure of angle SRP plus the measure of angle SPR equals 90. And that is because they are the other two angles in the triangles. They have to add up to
Uh-huh.
90 as well. So I'm not, that's where it's a little bit unclear for me what I should tell you to actually write over here. It's something like the other two angles in a triangle, in a right triangle, add up to a 90.
Uh-huh.
Is that stuff you've heard before in class?
No, I don't think we've gone over that theorem yet.
Oh no. Okay. Well. Uh, okay. Um, then okay, then maybe it's much simpler than that. Maybe it is that you say that these other two angles must be complementary.
Uh-huh.
So really 5 leads to 6, which is angle SRP is complementary to angle SPR.
Yeah.
Okay, and if so, that's the definition of complementary angles again. So if those are complementary, what we're saying is back in this picture, it's like, okay, this one and this one, they're complementary. And we just read that QRP
Uh-huh.
is complementary to PRS. So this one here is complementary to that. If if this is complementary to this, so 1 complementary to 2 and 2 is complementary to 3, then 1 must be complementary to 3.
Yeah.
Okay, so if that's true, then we know angle S here to Q R S. Okay, we know that angle 1 and angle 3 are complementary.
Uh-huh.
Um, and then I think we can prove that oh no, angle QRP is complementary to PRS.
Uh-huh.
Oh, I'm sorry. This is much simpler than that. I really sometimes I don't catch these. So they're telling you that they're saying that this angle is complementary to this angle.
Uh-huh.
So what does that mean?
That they add to 90
They
degrees.
add up to 90 degrees. So that's all we have to say for that point. So we know that that's a 90-degree angle now,
Mm-hmm.
and we know that that angle and S are 90-degree angles.
Uh-huh.
So we know that angle QRS, measure of angle QRS, is 90 degrees
Uh-huh.
because it's it's like the definition of a perpendicular angle.
Uh-huh.
And if we know that it's 90 degrees, we know that we also know that the measure of angle S is 90 degrees by
Uh-huh.
the same thing. It's a definition of a perpendicular angle. And 7, since these two angles are the same, we can say that angle QRS is congruent to angle S because two angles with the same measure are congruent.
Ah,
Two angles with the same measure are congruent.
okay, yeah, that means.
So I missed this. It said that Q to R to P is complementary to P to R to S. This angle and this angle, this one and this two, 1 plus 2, they add up to 90.
Uh-huh.
Since it adds up to 90, it's a right angle. Angle S is already a right angle, so you're already there.
Ah,
All right, so some general thoughts on these proofs that I think could be useful for you to know. The first is that no proof is like an algebra problem.
uh-huh,
And what I mean by that is when you did algebra, you generally wanted an example,
uh-huh,
and then they just changed the numbers. There's none of that here. There's not like, hey, I know how to do this proof, so when you just change the numbers on me, I can do the same proof.
uh-huh.
That doesn't work. Um, there's there's not as much what I call forwards and backwards. So a backwards proof here would be like if I tell you that if it, like you basically you switch these
Uh-huh.
for forwards and backwards. Like I'm giving you that these angles are congruent. Prove that this is complementary.
Uh-huh.
There's less of that. There's some, but there's less of that. Okay. So what all that means is you're kind of at a huge disadvantage as a student. You have to do as many proofs as possible, and maybe you overlap with what the instructor puts on the exam or the quiz, or you want to try and figure out where all the possible proofs can come from. First, so you're looking at your homeworks, you're looking at the chapter reviews, you're
Uh-huh.
looking at the cumulative review, which is what we just looked at. So that's how you kind of figure out what you think you can do to be able to be successful in this, because it's not that easy, and most people struggle um, in this in
Right.
this in this part of the course. But we can do a couple more here. Um, the uh, Number 10 is probably worth doing. Same thing with 11. Do you have a preference for 10 or 11 here in the cumulative review?
Uh, 10.
10. Okay. All right. So the thing we've got going here is that angle 1 is congruent to angle 2. So that means that angle 1 is congruent to angle 2. Angle
Uh-huh.
1 is also congruent to angle 3.
Yeah.
Okay. So um, we want to get to this point where we know that all three angles are congruent.
Okay.
That's kind of the first thing that we're leading to here. So we know that angle 1 is congruent to angle 2.
Yeah.
That's given. And same thing with angle 1 is congruent to angle 3. That's also given. Okay. So we also know that angle 1 is congruent to angle 3. And that's by the transitive property.
Wait, but isn't that given?
I'm sorry, angle 2 is congruent to angle 3. Sorry, 2 is congruent. So this angle is congruent to that angle.
Uh-huh.
So we know let's call this angle 4.
All right.
So here's what we know about angle 4. Angle 4 um, minus angle 1
Uh-huh.
is congruent to angle 2. I'm sorry, equals angle 2. Sorry. Is that something you've seen in class before?
No, not really.
Well, okay, so tell me how you've been doing the subtraction property then in class.
Uh, I don't know. We haven't really been doing the subtraction property that much.
Okay, let me just pull up I'm doing that on my side here. At the beginning of the chapter, it tells you like, here are the concepts. Apply the subtraction property of segments and angles, apply the addition property of segments and angles, apply the multiplication property of and division property of segments and angles. All right. Maybe I'm getting too far ahead of myself here. You've always got to look ahead at the conclusion. What does the conclusion ask you to prove?
That if FH bisects angle EF.
FH bisects, stop. Wow. Sorry, not you. I'm trying to get this thing to okay, there it is. FH bisects EFG. So if it bisects it, that means that the angles are the same. Have we proven that the angles are the same?
No. I mean,
Well, I think
what?
we have. I think we have here. Angle 2 is congruent to angle 3.
Oh, yeah.
Now, what I'm not sure about, and this is where maybe you've got to ask your instructor, do we need to go and say measure of angle 2 is equal to the measure of angle 3? That's the definition of congruent angles,
Uh-huh.
angle measures.
Yeah.
And I think you do. I think you have to go that far.
Yeah.
So there's generally like two, there's this like if something, then something, right?
Those are the proofs we've been doing.
So, say that one more time.
Those are the proofs we've been doing.
Okay.
Or the
So if the measure of angle 2 is equal to the measure of angle 3, then FH bisects EFG. Is that okay? Is like if something, then something.
uh-huh.
But here it's the reverse. It's like or I'm sorry, it's if FH bisects EFG. If this right here, FH
Uh-huh.
bisects EFG, that means that these two angles are congruent.
Yeah.
Do you remember what it is when it's the reverse? So if A, then B. Do you remember what it is if B, then A?
Uh,
I'm
not.
writing it down. The converse.
No, not really.
Okay, this is a big deal. This might be the most important thing that I say in regards to proofs. So often in the chapter, you are told this first one, like in the section notes.
Uh-huh.
You're told like if this, then this. If, and we did this earlier. Let me scroll up because you used it actually in this problem right here. If C is the midpoint,
Uh-huh.
then AC equals CD.
Uh-huh.
So if C is the midpoint, then AC equals CD.
Uh-huh.
Now, what's the converse of that? What's the flip of this? If AC is congruent to CD, then what? C is the
Midpoint.
midpoint. So this is the original, and this is the converse.
Uh-huh.
So oftentimes in this class, you have to either use the converse
Uh-huh.
or go back and say, okay, I have the original, which is true, so I can use that, or oh, I have the like the conclusion, so I can use the converse.
Uh-huh.
And I'm making hand motions here that you can't see, but the point is in this problem down here, you have the converse. You have angle 2 is congruent to angle 3.
Uh-huh.
The original would be if FH bisects EFG, then
Uh-huh.
angle 2 is congruent to angle 3.
Okay.
So you use the converse. Okay, so your reason over here is the converse of the definition of angle bisector.
Oh.
because the definition of the angle bisector is what tells you, that angle 2 is congruent to angle 3, but you already have that.
Yeah.
So you know that FH bisects angle EFG.
Uh-huh.
So all these things that I said out loud, these are like what you have to think. Like, I mean, you obviously can't say them out loud on your test, but you want to. That's where you're going. That's where you're going with this.
Uh-huh.
And I'm really hoping that was clear.
Yeah.
Okay. All right. Um, if you allow me, I would like to tell you about one other resource that might be super useful for you. Did you say that you have an exam on Tuesday?
Yeah.
Okay. I'm sharing my screen here, going to my website here. What I'm doing on Mondays at 7 p.m. is what I call a virtual homework help.
Mhm.
And it's just like this format, except we don't spend the full time. I don't spend the full time with you. I end up just spending about as much as I need, probably 5-10 minutes with you. But it's the, sorry, I didn't get it up here. It's right here. You would choose virtual homework help, and it's not currently available, but it'll show up at 7 p.m. on Monday.
Okay.
And if you have like one last question, I can answer you. Paul gets you kind of organized in order, and then I answer your question. So we could do another proof or something like that, or you could follow up with the question from the other day
Okay.
if needed.
Sounds good.
So that does end our lesson today. I'm gonna send you an email with the notes right now,
Uh-huh.
and then what I'm gonna do um, is follow up within 24 hours or less with the video, so you can see
All right.
it too.
Sounds good.
So I really appreciate you scheduling with me, and I look forward to helping you again, Manny.
Yeah, thanks for your help.
You're welcome. Have a good day.
Okay, you too. Bye.